All right, y'all. Good morning. Just kind of give you a rundown of what's going to happen today. You should have or be starting on your warm up if you've not already done so. Okay, that should take you about the first 10 minutes of class, and then for today you're not going to get those answers to that warm up. So I do believe that is number 30 for y'all. So we will move your quiz on that to Wednesday. Just kidding. Maybe Thursday. But anyway, we won't take that quiz tomorrow because I wasn't there to go over number 30 with you. So we will move that quiz to later in the week, regardless of when. So anyway, for those of you that were in class, if you were not in class on Friday and you did not receive the notes, you need to check the board real quick and get your copy off of the board, first of all. And if for some reason your name's not up on the board or you don't have the notes from Friday, you should left some blank ones as well out for the sub to give you if you needed them. But nonetheless, we got through. Both classes were in kind of different place, and obviously I'm not going to do two separate videos. So I do know that one of you got all the way through example number 6. And the other one got halfway through 6 into 7. Hold on one second, y'all. All right, my bad. Okay, so like I was saying, some of y'all had gotten through all the way through example number 6. The other class had to finish example number 6 and do example number 7. That was your homework for last night. So I'm just going to kind of go through these relatively fast, and then we'll pick up on example number 8, 9, and 10 together to finish out your notes from Friday. Okay. All right. So remember we talked about in example number 6 and in 5 that sometimes there are two different triangles whenever you're doing the law of sines. So I told you all before you left on Friday that the second angle the angle for the second triangle that we were dealing with in example number 6 was 133.2399. And then once we have this angle and the angle they gave us in the problem, now we can find angle Z here, which would have been the 180 minus the 133.2399 minus the 40. And you should have gotten for angle Z to be 6.7601. So there's angle Z, there's angle Y. So remember we were given 1, 2, 3 pieces of the puzzle, 4, 5. So we're missing the 6th piece of the puzzle, which is side Z. So we had side X and side Y here, so we're missing side Z. Okay, so again, I'm going to use what I was given, which is 40. So the sine of 40 degrees over 75, which is the length of the side across from the 40 degree angle, length of X, okay, equals, and then we're going to have to use this one, the sine of 6.7601 over what we don't know in this situation, which is Z. All right, and when you do that and cross multiply and simplify, you should end up with side Z being 13.7346. Okay, so that completes that triangle. That's what y'all should have done for homework. There wasn't anywhere to turn it in, but this is just the expectation of y'all to do what you're supposed to do. Okay, so you should have gotten those numbers right there. All right, so let's go to example number 7. All right, so again, I'm going to go ahead and draw me a triangle. And our triangle is D, F, and G. All right, they gave me that D is 69.8. All right, they gave me that side D, which is across from angle D, is 74.5. And side F is going to be 21.3. So that's all the stuff that's given. All right, again, when you're given two sides, obviously you can't just find that third angle just by subtracting like we did whenever we were given two angles. Okay, so we're going to go ahead and start with our law of sines. Okay, given what we go. So the best thing to do is use the ones we're given first. So sine 69.8 over 74.5 equals, and we want to use the 21.3. So we're going to try to find F first. So sine F over 21.3. All right, so I will write that out just in case you forgot how to isolate f. But just remember, here we're looking for an angle. So when we're looking for an angle, we got to do second sine. So if I move the 21.3 up, okay, so I'm going to do the sine inverse of 21.3 sine 69.8 over 74.5. That's all. You're typing that whole thing in your calculator. Okay. This is my calculator at home, so let me check my mode. See, I am. Okay, so I am in degrees, so we're good there. Okay, so sine inverse, so second sine. 21.3 sine of 69.8 over 74.5. So we're typing all that in, hitting enter, and we should get 15.5643. Remember, we're just cutting these off now. Okay, 5643. So 15.5643 is angle F. Once you find angle F, you've got angle D. We can do 180 minus 15.5643 minus the 69.8, and that's going to give us 94.6357 for angle G. So 1, 2, 3, 4, 5. All right, and then we got to find side G. So again, we're going to use the sine. We're going to use angle G. And you should end up with side G being, let me move this up some. Okay, side G's value is going to be, let's see, I'll draw that out over here. Okay, so if I'm doing G, so G here is going to be, so we're going to use sine of 69.8 over 74.5 equals the sine of 94.6357 over G. So to find that one, it's going to be 74.5 times the sine of 94.6357 over the sine of 69.8. And you should get 79.1228. Okay, so then when we go to find our second triangle, remember, you're looking back right here at when you took the sine inverse and you got this value right here for angle F. Okay, so if you did this, remember to find, so this is the or. Okay, you would have to take this angle and do 180 minus that angle because sine is positive in 2 quadrants. And when you do that, it's going to give you that angle F is going to equal 164.44. Okay, now I'm going to go ahead and tell you I know that's not possible, but we're going to see mathematically why it's not possible. So if we were to not realize that it's not possible, okay, then you would take 180, this will be to find angle G. It'll be 180 minus 164.44. It'll be more than 44, hold on. .4357, sorry. Okay, so 180 minus 64.4357. Okay, minus the 69.8 that they gave us. And you're going to get that angle G is a negative number. Okay, and we know that's not possible. Okay, so that means there is not a second triangle in that situation. Okay, all right, so that's what y'all were supposed to work on over the weekend. So now we're going to jump to example number 8. So this is new for everybody. So everybody should be in the same place at this point. Even if you weren't here, you need to be jumping in right now, making sure you're catching up on everything from here on out. Okay, so solve triangle ABC where angle B is 118. Side B is 8 and side C is 10. All right, well, let's see what happens. So they gave us B and B, so we're going to go ahead and use that. So sine 118 over 8 is going to equal, we don't know C. They want us to find the whole thing. So they gave us side C, so we're going to start with sine C over 10. Okay, so if I was to cross multiply, rearrange here, and I'm trying to do a sine inverse, right? So sine inverse of 10 sine 118 over 8. Okay, let's see what we get. Second sine, Lord. Okay, alpha y equals, oops. All right, 10 sine 118 over 8. Oh no, I get an error. Okay, and let's talk about why we get that error. So whenever you, so we know real quick, we know angle C is not possible. And here's why. Okay, when you're talking about triangles in general, okay, if I was to draw this triangle out, if I was to draw this triangle out, angle B is going to be 118. Side B is 8 and side C is 10. Sorry. Okay, so what you know about a triangle is that if this angle right here is 118 degrees, no other angle can be obtuse. Okay, they can all be acute. You can have a right and two acutes, but the minute you have one obtuse angle, no other angle can be larger than that. Okay, so the problem with that is also the largest side is opposite the largest angle. Whether it's a right triangle or any triangle, the largest side is opposite the largest angle. So now, if 118 is now my largest angle because it is obtuse, all right, then 8 and 10, then 10 would have to be over here. So see, 118 and 8 would not be proportional. Like 8 is not the longest side, but 118 is going to be our largest angle. So that's what's making this triangle not possible. Okay. All right, so moving along into the area of a triangle, which y'all know the area of a triangle, okay? 1/2 base times height. And remember, normally the base and the height, whenever we do this, the base and the height are going to make a 90-degree angle. So that is what you know. So whenever I ask you about this triangle, you would normally come in here and you would have, it would already be marked, or you would have to do it yourself perhaps. You would drop a perpendicular, okay? And this is our height. Okay? But this is what they are telling me the formula is. And this looks different than this, but let's see how they're getting this. Understand, the original triangle here was not a right triangle. Okay, the original triangle is not a right triangle, but let's look at the right triangle. Okay, if I wanted to find C, right? So that would be opposite, because we're using sines here, y'all, so we're going to use that. So opposite and hypotenuse. Okay, so for that, the sine of C would equal, the opposite would be our height, and our hypotenuse would be A. So if we solve that for the height, just move the A up with our little, slide. A sine C equals the height. And then if I went down here and wrote out this formula, area equals 1/2 base times height. And I can plug this in there. So our area equals 1/2 B times A sine C. And if you rearrange this and just put the AB together with the sine of C at the end, you get this formula up here. Okay, and we could do the same thing here. We could go from A and we could do height over C. We could go B, we'd have to drop a different perpendicular for B. I'm sorry, we'd have to drop a different perpendicular for A too. But we'd have to drop a different perpendicular in order to do B. But nonetheless, you could do the same thing here, okay? But these are your formulas for the area of a triangle that is not a right triangle. Notice the two sides you have you use the angle that's not related. So if I have AB, it's going to be sine C. If I have BC, it's sine A. And if I have AC, it's sine B. So your angle is the one side that is not included. All right, so let's look at the last two examples there. Example number 9, triangle ABC. Triangle ABC. Okay, so I'm gonna go ahead and see what we're dealing with. They gave us B, they gave us C, and they gave us A. Well, that's perfect. They gave us two sides and the unincluded angle. So we can just plug this straight in. So K is gonna equal 1/2. They gave us B and C. So 21.2, C is 16.5 times the sine of A. And we're just gonna type that straight into our calculator. Okay, 1/2. Y'all, I do not usually spend the time to type that fraction in, just so you know. I would put 0.5 or I'd put it in parentheses or something like that. All right, 21.2, 16.5, and sine 25. So our area here is 73.9159. That's all there is to it. All right, so let's see what they gave us in example number 10, last one. All right, triangle MNP, they gave us side M, side N, and side M, angle N, and angle P. Okay, well, I'm missing a side. So in order to do our area, okay, we're going to have either side. You can find N or you can find P. But we're going to have one or the other. So let's see what we got. We can find angle M. Pretty easily, right? Because they gave us the other two angles. So angle M is going to equal 180 minus the 111.1 minus the 27.3. So for us, angle M is going to equal 41.6 degrees. All right, so then let's see. We've got M and M. So let's use that. So sine 41.6 over 45.7 equals, and we can find either. I'm just going to find N because it's first. So sine 111.1 over N. Cross multiply, rearrange. So you know it's going to be N equals 45.7 times the sine of 111.1 over the sine of 41.6. So I got 64.2179 for N. Okay, so now I can use my formula. So I have side M, side N. I have those two sides, so I'm going to use angle P. So K is going to equal 1/2 side M, side N, and the sine of angle P. Okay, because again, M, N, P. You always have those have to be three different letters. Okay, you can't use the same one. All right, so let's type that in. 1/2 times 45. Please don't just sit there and wait for me to type it in and just copy this down. Y'all need to be working these out as well yourself. And I know right now some of you are feeling attacked, and that's probably because you're not doing what you should be doing, which is working it out yourself, not just letting me type it in and waiting for me to do it. Okay? All right, so here the area of our triangle is going to be 673.0127. And we are done. All right, so we are done with our law of sines notes. Now, your assignment for the after we get done with the next set of notes, but your assignment for the remainder of the day, today and into tonight, is your actual worksheet for the law of sines notes. I'm pretty sure. If I, for some reason, I change that by morning, then obviously I'll have that in my sub plans, and my sub will make that adjustment. But for right now, my intention is to give you T5L7 worksheet as homework for the law of sines. Okay. If you were not here, there's not a video from Friday. So you need to get those notes from somebody. I'll try to make one. I forgot to record Friday whenever I was teaching. So you do need to get those notes from somebody to fill in the rest of this note template. Okay. All right. So at this time, we need to move on to the law of cosines. Okay. So if we have not passed out the sheets for the law of cosines yet, then pause my video now. Somebody walk up and pause my video and allow the sub time to pass out those sheets so that we're not trying, I'm not ahead of y'all and whatnot. Also, phones, I totally forgot to mention this at the beginning. You know where your phones are supposed to be. I'm well aware that some of y'all don't follow that rule, but do not have them out during class just because I'm not there. That's not how that's going to work. They're supposed to be in the caddy where a calculator is. Please do what you are supposed to do. All right. Test 5, Lesson 8, the law of cosines. So Friday was the law of sines. It's just a formula to remember, not a super hard formula. And then today we're going to talk about the law of cosines. All right, so for any triangle ABC in which A, B, and C are the lengths of the sides opposite the angles with the measures A, B, and C. Okay, so nothing new yet, right? Sides are small, angles are large. Then here is your law of cosines. Now, these are a little bit more difficult than law of sines. Okay, so just bear with me. All right, so we've got A squared equals B squared plus C squared minus 2BC cosine A. All right, and I'm going to write the next two. Okay, and you're going to see there is a pattern here. All right, I'm going to do my best to pause occasionally in this video, y'all, so that you're not behind, because I do write fast and I do talk fast. So I'm going to try to slow down a little bit, okay? All right, you're going to see there's a pattern here. Notice that whatever side we have over here, that's whatever angle we have here. So A, B, and C. And then these two letters match these two letters. So if we have B squared, C squared, we have BC. A squared, C squared, AC, AB, AB. Okay? And this is just, this right here is just your Pythagorean theorem. Okay, normally we see it like this, C squared equals A squared plus B squared, right? But this is just solving for a different side. Okay? But that is the Pythagorean theorem. But we're not necessarily dealing with right triangles here. So, Pythagorean theorem obviously applies to right triangles, but that should, the formula itself should just look familiar for you there. Okay. Keep this, accessible so that we can refer back to it as we go through today's notes. All right. Find the length of side C for a given triangle. All right. So they gave us this triangle here, which gives me side C, angle C, and then sides B and A. Okay, so let's level that real quick so you know. Remember, A is across from A, C is across from C, and B is across from B. All right, so they gave us angle C. So I'm going to need to use the one with angle C in it. That's the only angle I was given. Okay, so I'm going to use that one. So that's going to give me C squared. Well, we don't know what C squared is. That's what we're going to try to find. Equals, A in this situation is 10. B is 14, so 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 60 degrees. Okay, so there we are. And we are just literally typing it right in. Okay, 10 squared, close this out. All right, 10 squared plus 14 squared So what that tells me is that when I type all this in, it tells me that c squared equals 156. But we want c. So we've got to go and take the square root of 156. And we get 12.4899. Okay? Straightforward. Just plugging stuff you know straight into the formula. All right, now example number 2. So example number 1 just asks us to find side C. Okay, but example number 2 tells us to solve the triangle. So remember, if we have to solve the triangle, there are 6 parts. 1, 2, 3 are given to me. So I am responsible for finding the other 3. So let me draw me a triangle here. Okay, we know this is 98.1. This is A, B, and C. So this is 98.1. A, which is the side opposite of A, is going to be 17.2. And B, which is the side opposite, I'm sorry, C, which is the opposite of C, is going to be 21.5. Okay, so now I've labeled my triangle. Remember, we don't know what B is over here. And we also don't know angle A or angle C. All right, so let's see what we can find out. We were given B. We were given A, so we can use the law of cosines. All right, so we're going to go B squared equals A squared plus C squared minus 2 AB, or AC, sorry, times the cosine of B, which is 98.1. Okay, so typing all that in. All right, so I get 862.3005. So that is for B squared. Okay, now you could have typed in the square root of 862.3005, okay, and gotten the same thing. Notice it does come a little bit different. 3, 6, 4, 9, 5. Then it goes to mine's. This one's 3, 6, and this one's 4, 7. Remember, this is not a rounded value. If I do the square root of this whole thing, okay, it's still going to give me the 4 decimal places I need. 29.3649 is what we're going to go with. Okay, so we found side B. So we've got all 3 sides. So now we need to find our other angles. So let's just find, we were given either side, and we've got these 2 right here. Okay, so sine 98.1 over B is now 29.3649 equals, we'll just do A first, the sine of A over 17.2. Again, 17.2 is going to jump over. It's going to be sine inverse of all of that. And let me just double check my math. Second sine. All right, second sine alpha y equals 35.4427. And that is angle A. Okay, so we know angle A is 35.4427. So now to find the last thing we need, which is going to be angle C, it's going to be 180 minus 98.1 minus 35.4427. 46.4573. Okay. All right. Example number 3. All right, again, we're solving the whole triangle, so 6 total parts that we need here. Okay, so we've got triangle PQR. Let me draw that out. Let's put P up here. Ooh, they only gave us sides this time. So P is opposite of P, Q is opposite of Q, that's a 3, and R is opposite of R. Okay, so you could pick any of the law of cosines you want to use, any of them. Okay, it really doesn't matter. I'm going to do R, but it doesn't matter. You can do whatever you want to do. Okay, so if I do R, then it's going to be R squared, which is going to be 51 squared equals P squared plus Q squared minus 2 times P times Q times the sine of R. Okay, so if we're looking for sine of R, remember, if we're looking for an angle, it's going to be sine inverse of something. Okay, so let me finish this out real quick. Okay, that's going to give me 2601 equals, that's going to give me 3370 minus 335 times the why did I put, that's cosine, y'all. Lord help me. Cosine R. Y'all about to figure out in these notes why I don't do any work past like 9 o'clock at night, because it is almost midnight as I'm doing this. All right, so if I'm going to solve for the cosine of R, so I'm going to move the 3370 over. Okay, it's going to give me negative 729.69. See, I'm telling y'all, done jinx myself now. All right, equals negative. All right, so we're going to do cosine inverse of negative 769 over negative 3354. Okay, so I got angle R to equal 76.7454. Okay, so 1 part, 2 parts, 3 parts, 4 parts. Okay, now y'all, I don't use the law of cosines continually unless for some reason I have to. I'm going to go to law of sines because it's easier. Okay, so now I have an angle R, I've got side R, so let's start there. Okay, so I'm going to do sine of 76.7454 over side R, which is going to be 51, equals, and it doesn't matter which one we find next, let's go sine P over 43. Okay, rearrange for that. And we should get that angle P is going to be 55.1527. That should be angle P when you cross multiply and simplify there. Got angle P, angle R, we're looking for angle Q, so I'm literally just going to subtract, remember? So angle Q is going to be 180 minus angle R over here minus angle P over here, and I should get 48.1019. Okay, 3 angles, 3 sides, we're done with that one. Okay. Good news is there were only 2 pages to your notes today, not like 4 and their halves, like 2 pages total. Okay, so go ahead and flip that over. And let's look at example number 4. All right, example number 4. A field is triangular in shape with sides 473, 512, and 734. What is the measure of the angle between the longest sides? So here we go. Let's draw it out. Boom, boom, boom. 734 can be one. It doesn't give me even any letters. You can label it if you want to. Okay, just as long as I got 3. All right, so the measure of the angle between the longest sides. Well, the longest 2 sides are 734 and 512, so we're looking for the angle between that. Okay, so remember, if we're looking for this angle, its side is what's on the left. So if I go back again, if I'm looking for angle A, then side A is over here on the left. Okay, so if I'm looking for this, then its side is the 473 squared. All right, let's use the other two. 512 squared plus 734 squared minus 2 times cosine, Miss Johnson, of the angle we don't know. Okay. Let's do some math. All right, so go ahead and I'm going to pause right here. Let y'all try to work that out for a second. I'm not even going to pause my video. I'm just going to wait a few minutes. You need to be working that out. So you're going to start with this side, rearrange until we can do cosine inverse. All right, let's see what we got. Give me some numbers here. So 473 squared should have given you and I'm going to keep going. So 512 plus 734. All right, multiply 2 times 512 times 734. Should have given you 75. And then cosine of theta. All right, so moving forward, working this out. I'm going to subtract the 800, 900 from the left side, which is going to give me negative. Okay, so cosine inverse would be negative 577,171 over negative 751616. All right, so our theta here that they're asking for is 39.8337. Don't forget your degree sign. All right. Last example of our notes for today. All right, find the area of triangle XYZ if X is 24, Y is 52, and Z is 30. So again, they gave us all 3 sides. So X, Y, and Z. X is going to be 24, so that's going to go over here. Y is going to be 52, and Z is going to be 39. We want to find the area. All right, so let's see. It doesn't really matter. Just pick your angle. Let's do angle X. Okay. So if I also do angle X, right? I would need the angle. I gotta have one angle, so let's just go ahead and find one angle. All right. We're going to find angle X. So side X, so I'm finding angle X. So we're going to use side X is going to be on the left. So 24 squared equals 39 squared plus 52 squared minus 2 times 39 times 52 times the cosine X. All right, pick up calculators. Get your fingers moving. Let's go. Calculate it out. 24 squared. Work mine out off camera while you're working it out. Don't just sit there and wait for me to do the work. All right, so when I did all this math, here we go. Cosine inverse of that whole angle right there gave me that angle X is equal to 25.8872. Okay, now they wanted me to find the area. So now that I have angle X, I want to use angle X to find the area. So we're going to say K equals 1/2 the other two sides. So if I'm using angle X, I need to use the two sides that aren't X. So 39 times 52 times the sine of the angle, 25.8872. Okay, and we're plugging that straight in as well. All right, so again, I'm just going to use parentheses for that. So side, our area here, after we found angle X, is going to be 442.7132. And we're good to go. All right, so truthfully, it's just plugging into the right formula, manipulating that formula to get what you're looking for. Okay, so obviously here we go. Just a summary of when to use what. If they give you three sides, the only thing we can do is the law of cosines. Two sides and an angle opposite one of them. Law of sines. One side and two angles. Law of sines. And two sides of the included angle is going to be the law of cosines. All right, so as you're looking through, again, you're going to be doing the law of sines homework right now in class. Don't wait until you get home. You need to be working on it now. And then we will talk about the law of cosines tomorrow. And let's see, I believe your test, if I'm not mistaken, I believe your test is Wednesday. Okay, so tomorrow will be a review for us. And then your test will be on Wednesday. And there is tutoring on Tuesday after school. Okay? All right, so you're working on T5L7 for the remainder of class. And then I will have copies of T5L8 as well. And I will have direct instructions for the sub on what to do from there. Okay? All right, I will see you all tomorrow. Make sure you study over everything. Make sure your warm-ups are up to date. We'll go over warm-up number 30 tomorrow whenever I get back. And y'all have a wonderful afternoon, and I will see you all tomorrow.